Hello, everyone. We are Team 11, presenting our project of machine learning for signal processing.
The project that the team is studying on is the ASVspoof challenge, and we name our proposed method CONAN, spoof detection with computed noiselessness and nonlinear fusion. So what is spoof? And why is it important to detect it? The voice speaking to you right now is one example of spoof. With the rapid growing of speech synthesis technology, we need stronger countermeasures to keep us secure. For example, you don't want people to fake your voice ID and unlock your phones. ASVspoof challenge is in competition for detecting voice spoofing attacks. In this competition, you are given an audio sample and your model needs to figure out if it is synthesized or spoken by real humans. The team acquired the training, development and evaluation datasets of the logical access task all from ASVspoof 2019. The table presented here summarizes the size of both bona fide and spoof samples for each dataset type. As it is tabularized, the spoof samples possess nearly 10 times the size of the bona fide samples. Our baseline model is a GMM model trained on LFCC features from ASVspoof 2019. We propose a new countermeasure for spoof detection. We trained GMM models on multiple coefficient features with improved window length. We also introduced silence as a feature for training. In the end, we performed nonlinear fusion using all these base models. We tested different window lengths for processing speech signal, and found that 25 milliseconds window performs better than 30 milliseconds and 20 milliseconds. Our single feature model significantly outperformed the baseline model by simply changing the window length. Furthermore, our fusion models have much better performance than base models. On frame level fusion model, base model scores for every frame are aggregated to produce a more robust performance. On instance level, scores of an audio file is aggregated. With this two-level fusion, we achieved huge performance gains. And our model performed almost as well as the best non-neural network system in the ASVspoof 2019 competition. We could rank number 9 on the leaderboard, only if we attended this competition. One of the largest issues we face is, the training data cannot entirely fit into computer memory. We implemented a workaround by fitting multiple data chunks into the same GMM model, and we found out that this method is better result than using only a subset of the data. On configuring window length, the frame level fusion has a limitation that all features in the fusion needs to use the same window length. On experimenting with the fusion methods, we found out that the more models we add to the fusion, the better performance we get. As far as now, we have not encountered a cap on performance improvement. Also, even adding poor performing models would also result in a performance improvement. The only exception was the model trained on silence features. On modeling and utilizing the silence and audio samples as feature, we found the approach of measuring silence length and directly using them as feature not effective. Further exploration in how to better model silence is needed. In conclusion, we proposed a new countermeasure against spoof attack using nonlinear fusion and silence feature. Our best model ranks high on the ASVspoof 2019 competition leaderboard. And that's all for this introduction. More details can be found in our paper.
Thank you guys for watching this video.